All right, so in this set of notes, we're talking about the logarithmic function, and there are some historical facts for you and examples of how we use logs in real life. But really what a log does is it gives us a way to find the exponent for an exponential equation. So if we have b to the y equals x, well, b is always our base. So even when I write log, I have my small base, and then the answer of a log is the exponent. Yeah, so when we have an exponential equation that we can't solve, for example, 2 to the x equals 12. Well, I know that this answer is going to be between 3 and 4 because, so 3 less than x, less than 4, because 2 to the third is 8, and 2 to the fourth is 16. So there's no exact integer value for x, but I can use my log to say that log base 2 of 12 is going to be the exact value of my exponent. If I want the approximate value, I can put it in my calculator. So in my calculator, if I do alpha and then window, I have an option here for log base. That's number 5. So you can either use your arrows down or you can just type number 5. My base is 2. My input is 12. We know it should be a number between 3 and 4. And sure enough, we get 3.58 approximately. So this is our exact value. And the approximate value was 3.58. Okay, so that's just an introduction to what a log is. Our most common bases are 10, and normally if it's base 10, we don't write the 10, we just write log x. And the other base that's super common is base e. It's so common, in fact, that we shorten it down to ln, which is the same as log base e. And it's so common that on our calculator, we have both a log button, so this would mean log base 10. We also have an ln button, which means log base e. And we're going to talk about the natural exponent and natural log later on. Okay. Since log gives us the exponent, the exponential function and the log function are inverses of each other. So if this is the graph of my exponential function, the inverse is the reflection over the line y equals x, and so here's my log function. So looking at this, I have an asymptote at x equals 0. So the domain of the log function is x greater than 0. My x-intercept here, so I'm shifting the y-intercept. When I reflect it, it becomes the x-intercept. I know that this is the point 0, 1. So on my log function, it's the point 1, 0. This tells me that log base 10, or really base anything, log base b of 1 is 0. That's because this is the exponent. So anything raised to the power 0 is going to be equal to 1. It's my vertical asymptote. Remember, we will never have a negative number as our result of exponentiation. So remember, we had y equals 0 as our horizontal asymptote because no matter what power we raise this to, we always get out a positive answer. Here's the answer that we're getting out, so we can only put positive numbers in. So x greater than 0. My answer, though, the exponent, could be positive or negative, which is why our domain is greater than 0. Our range is all reals because the exponent can be positive or negative. Our logarithmic function is monotonic increasing. We're always going up, although as x gets greater, we go up more slowly.